Welcome to our video on factoring using the distributive property, and I probably should have put and grouping there, but I guess when we group we use the distributive property also. So it's going to be factoring using the distributive property. Let's get started here. If this says factor the expression completely, the key word here is completely, and that seems to be what throws off most people who have trouble factoring completely, is that they factor, but they don't factor down as much as possible. It's kind of like, say we have a fraction 16 over 24, and we want to simplify it. Well, 8 over 12 is simplified, but it is not the most simplified version. The most simplified version is probably going to be 2/3. And so this is what we're trying to get. We're trying to not stop here, but we're trying to get to this point when factoring completely. So let's think about it. Factor the expression completely. What do you see that goes into x to the fourth that also goes into negative 9x squared? Well, you see an x, right? There's an x on the left and there's an x on the right, but how many x's are there that you could pull out? Well, if there's x squared, I'm sure you can pull x squared out of x to the fourth. And so how are we going to do that? X squared times x to what power is x to the fourth? Well, what do you have to do with these exponents? Remember, you're supposed to add them. So 2 plus 2 is 4. And then we have minus 9 times x squared. And what do you see that's in both of them? Well, we see x squared. So we go ahead and pull it out. So we have x squared, and then inside the parentheses, x squared minus 9. And so far, you have factored out x squared, but you have not factored completely. And in doing this, remember, you should always know your perfect squares and know that 9 is a perfect square, and x squared is also a perfect squared. So we can factor x squared minus 9, and this is going to be the difference of 2 cubes. Or, I'm sorry, I don't even know what I'm thinking here. Those are square numbers, not cubes. But that's the difference of perfect squares. So we just drop down x squared. Now, x squared minus 9 will factor into x minus 3, x plus 3. You should already have this memorized and know that when you have the difference of perfect squares, it factors down quickly like this. And so now you have factored completely. Let's look at this one here. Let's figure out what numbers come out of 7a to the 6th that also comes out of negative 21a to the 4th. How about a to the 4th? Can I get a to the 4th out of a to the 6th? 7 times a to the 4th times a to what power is going to be a to the 6th? Well, it must be 2, because we add 4 plus 2 and get 6. Negative. Now, if we have a 7 over here on the left term, can we pull a 7 out of the right term? Can we pull a 7 out of 21? Yes. 7 times 3, right, is 21. And then we have a to the 4th. And so if we pay attention, a to the 4th and a 7 is in both of them. So that's what number comes outside of the parentheses. 7, a to the 4th is outside of the parentheses. And what's left inside? A, and then negative 3. And I said a, I meant a squared. A squared, and then your negative 3. Now, a squared is a perfect square. Now, what about 3? Is 3 a perfect square? No, 3 is not a perfect square. So that's the reason why, when we are looking to factor this, we will leave the answer like this. Now, you might say in the previous problem, we factored x squared minus 9 down. Well, we did that because x squared was a perfect square, and 9 was also a perfect square. The square root of 9 is 3. if we go to the example we're on now, what's the square root of 3? That's going to not be an easy number to write. It's going to be a decimal, and it's going to take up a lot of paper if you try to write it down. So it's not a perfect square. So 3 is not a perfect square. That's the reason why we don't factor it down into any further. See if you can figure out what factor you will pull out of this expression. Pause the video, see if you can figure out what number you pull out, and then, or what factor you pull out, and then we'll go from there. You can play it and see how I've finished the problem. I know that R is the lowest variable, is the variable with the lowest exponent. That's what I was looking to say. And I know that 24, 20, and 4 all have one number in common, and that is 4. So 4r cubed is going to be broken down into 4 times r squared. 20r squared is going to be broken down into 4 times 5 times r, and 24 is broken down into 4 times 6 times r. And let's circle what they have in common. 4r, and also 4r. And so that's the number that comes outside, 4r. That's outside of the parentheses. Now what do we have left inside the parentheses? R squared, you have a positive 5r, and you have a positive 6. Now remember the word completely, factor it completely. Since a here is a 1, since a, and I'm looking at this as a quadratic, ax squared plus bx plus c, since the term in front of the squared variable is 1, can you give me two numbers that multiply to get 6 and add to get 5? Those two numbers are 3 times 2 is 6, and they add together to get 5. So therefore, we will be factoring r squared plus 5r plus 6 into r plus 3 and r plus 2. And we have factored completely here. Once you see a trinomial like this, you should be thinking that you can factor it into two factors like that. Put it into 2 parentheses. And in this case, you could. So there are your 3 factors. 4r, r plus 3, and r plus 2 are your factors. You go ahead and try this one on your own. See if you can completely factor this one on your own. And then check your solution with mine. I know that 5s goes into all 3 of them, and that leaves s squared plus 6s plus 8. Yep. And then since a is 1, give me 2 numbers that multiply to get 8 and add to get 6. About 4 and 2. 4 and 2 is it. So therefore, our final factors are going to look like s plus 4, s plus 2. Completely factored right there. Now, factor the expression completely. What number or variables, what factors can you pull out of this expression? I'm looking, x, x, x. There's an x in the first 3, but no x in the last term of 6. So you cannot factor out an x. You can factor out a 3 and a 3, but no 3 here, and definitely that's a 1. No 3 comes out of 1. So we can't factor any numbers out of here. No variables either. But you're used to factoring trinomials, quadratic trinomials, by grouping. So let's look at x cubed plus 2x squared. What factor can you pull out of this? You can pull out x squared, right? So we have x squared. If you take out x squared out of this, if you take out x squared out of x cubed, you're left with x. It would look like this if you're trying to solve that out. And then you divide this by x squared, and those cancel, and you're left with plus 2. So we have x squared, and then x plus 2 inside. And what comes out of 3x plus 6? Well, we know, I think, positive 3 does. So if we divide that by 3, those cancel, and you're left with x. Divide 6 by 3, and you get a positive 2. This is a grouping. You're going to factor this by grouping. You've done this before, at least if you've factored trinomials, factored quadratic trinomials. You've done it like this before. And make our 2 final parentheses. And this is what we have. Now, since this is x squared, you should be thinking, are you able to factor this further? And x squared and positive 3, x squared is a perfect square, but positive 3, number 1, it's addition. It needs to be the difference of perfect squares. And then 3 is not a perfect square. So we'll leave it like this. We'll say that that's factored completely. So let's see, you go ahead and try this one. If you need one more example, pay attention, I'll work it out. If you feel like you can do it on your own, go ahead and do that. You're going to pull out m squared from the left underline, and that leaves you with m minus 1. And then from the right underline, you're pulling out a positive 4. And if you divide that by 4 and divide that by 4, you should get m minus 1. Put these two together. So m squared plus 4 comes into 1 parenthesis there. And then m minus 1 and m minus 1 gets its own parenthesis together. And if you look, m squared is a perfect square and 4 is a perfect square. But that is not the difference of perfect squares. The difference means you have to have a subtraction sign in between them, and it's an addition sign. So we're going to say that this is factored completely. You notice I don't even pay attention to the m to the first power, because you're not going to be factoring it any further than down to the first power. Try these two on your own, with keeping in mind you should factor completely. You should factor completely. I know x cubed is x squared times x, and then minus 2 times x squared, with x squared being the factor that you can pull out. That leaves x minus 2 inside the parentheses. On the right side there, you have negative 9x plus 18. So if we have negative 9 times x and positive 18, well, I'm going to change 18 to 9 times 2. I'm doing some forward thinking here, and I need x minus 2 inside the parentheses. So therefore, if I just pull out 9, I'm going to be left with negative x and a positive 2. It's not really going to help us out because these parentheses need to be the same. So let's pull out a -9, which leaves a positive. Pull out -9, and those 9s and the negative signs cancel. You're left with positive x, and if you pull out a -9, 9 cancels with 9, and a positive divided by negative will leave us a -2. And so this is where we're at. Go ahead and take x plus 2 and x plus 2. That would be x squared and -9. They get their own parentheses. And then x minus 2 will go into another parentheses together. Remember the keyword, factor completely. I know x squared is a perfect square. I know 9 is a perfect square. And the subtraction sign means that we have a difference of perfect squares. So therefore, x squared minus 9 factors into x minus 3, x plus 3, and then, of course, x minus 2 at the very end. All those variable x's have a power of 1, so we know that they can't be factored anymore. And this one here, try this one on your own. Check your solution with my work. Make sure you pause the video, work it out, and then if you get stuck, you can play it and see where you're getting stuck at. AH cubed minus 3h squared. I know since I have h squared on the right, h squared is going to be the highest that I can pull, the highest factor I can pull out. So 8 times h squared times h, that'll give us 8h cubed. And then we have minus 3 times h squared. What do they have in common? H squared. And what do you have left over? 8h, and then -3. Over here on the right, you have 16h minus 6. What's the greatest common factor that goes into 16 and 6? Looks like it's going to be 2. So 2 times 8 times h is 16h. And then we say minus 2 times 3, and that's going to give us -6. What do they have in common? They have a 2, that's a positive 2. So we'll say plus 2, and then inside the parentheses, 8h and -3. Put these together, h squared and positive 2 go inside of one parentheses. 8h minus 3 will go into another. This is not the difference of perfect squares. H squared is the only square there is in there. So therefore, you have factored completely. That'll be all we have for today. If you have any questions, you can catch us on the next one, or you can let us know. Thanks for stopping by.